Welcome to Algebra 1, Unit 7, Lesson 4.5, Part 2, Compound Inequalities. Pearson Algebra 1, copyright 2009. I'm Mr. Pilarski, and our objective today is I will be able to solve and graph inequalities containing OR. In Part 1 of this lesson, Compound Inequalities, we talked about graphing and solving inequalities containing the word and we saw in that lesson that that was a solution set that contained the numbers between the two values that we solved for. In this particular lesson, we change gears a little bit and switch over to the idea of or. It has to be either this or that, and a lot of times, not always, but a lot of times, we end up having graphs that are extremes. Let me show you what I mean by our extremes. If I gave you these graph, or the inequality, I should say, the inequality to graph x is greater than 3 or x is less than -2, if we were to make a number line, we would put the -2 over here, the 0 would be right about here, and +3 would be right about here. And when we graph these things, we really just end up graphing them piece by piece. Unlike compound inequalities with the word and in it, we can't make it a shorter version. It's going to stay like this. It's going to end up being two inequalities joined by the word or to make a compound. We just graph these piece by piece. So x is greater than 3. So we use an open circle on the 3. And since it's greater than, we shade to the right. And then we graph x is less than -2. Open circle on the -2, and we shade to the left because that inequality tells us to. It says x is less than -2. Less than is to the left, greater than is to the right. Now, not all the time will the graphs look like this. Sometimes we'll be given things such as x is less than a 3 or x is less than a -2. We would change that then. The graph would look basically the same. The number line would anyway. Here having our -2, 0, and 3 a little bit further away. Graphing this here, x is less than a 3, we'd have an open circle on the 3, and we would shade to the left. We wouldn't even need to really graph this x is less than a -2. If we did, we'd put an open circle on the -2, and we would also shade to the left. So there'd be a lot of times in these situations where you may have overlap and a lot of times where you may not. So let's take a look at example 4t, writing a compound inequality. Write a compound inequality that represents each situation. Graph these solutions. Part A, all real numbers that are less than 0 or greater than 3. This should be pretty easy to translate. Less than 0 or greater than 3. We really don't have a variable, so we could write one. So for the first one, x is less than 0. X is less than 0. It should be a pretty straightforward translation. Or x is greater than 3. So we need to take that. We did the writing the compound inequality part. Now we need to make a little graph. Since I have enough numbers on the number line here that I have, or enough tick marks, I can make a fairly nice and accurate graph. Starting at -1, I numbered a 4. Starting at one number below 0 and one number greater than 3 to number my number line. And on 0, I use an open circle because it's x is less than 0, and I will shade to the left because it says x is less than 0. On x is equal to 3, or greater than 3, when x is greater than 3, I'll use an open circle because it's no equal sign in the inequality. And I'll shade to the right because it says x is greater than 3. We can see 4 is plainly greater than 3. Part B, discount tickets are available to children under 7 years old or to adults 65 and older. So we have to break this down. The discount is available to children under 7 years old or to adults 65 and older. So the people that get discounts are children under 7 years old. That would imply that the person's age has to be less than 7, or a person's age has to be 65 and older. So that would be greater than or equal to 65. So anybody that's under 7 or 65 and older get a discount. So making a pretty easy number line, just using the marks to mark these numbers off. Open circle on the 7 and shade to the left because that would be children under 7 and 6, 5, 4, so on and so forth. And on the 65, we use a closed circle because a person that's 65 gets the discount. And anybody older than that, 66, 67, 68, so on and so forth. That was example 4T, writing a compound inequality. Example 5T, solving a compound inequality containing OR. Solve and graph the solution. Well, we'll graph the solution like we just did in example 4T after we solve it. Now, the cool thing here is that we have to solve two separate inequalities. It's not like solving with the word and, where we had the three different parts. We actually have to solve two separate inequalities that are separated by the word or. So on the left-hand side of the word or, we have 3x plus 2 is less than negative 7. Well, to solve that inequality, we subtract 2 from both sides. The 2's on the left cancel out, become 0, actually leaving us 3x is less than negative 9 on the right. Next, I divide each side by 3. The 3's on the left divide out, leaving me x is less than a negative 3. Bringing my OR down. And on the right-hand side, we have to solve a separate inequality. We have to subtract 5 from each side. In doing so, the minus 5 plus 5 are opposites. They go away, leaving us negative 4x is less than. And on the right, we do the math. That's a negative 4. Next, I'll divide each side by a negative 4. Now remember, when you divide each side by a negative 4, what do you have to do with the inequality? That's right, you have to turn it around. So x is greater than positive 1. So our solution here is x is less than negative 3, or x is greater than 1. So that's our solution. Now we need to graph that solution. And it can be a pretty basic number line. Draw a line, put 2 marks on it. One for negative 3, one for 1. And then use your circles. On the negative 3, I need an open circle. And I need to shade to the left because it says less than. Something I use in my class is the less than and to the left. The beginning sounds for both of the words are L. I use an open circle on the 1, and we shade to the right because it is greater than. When you're solving compound inequalities with OR, you have to solve two separate inequalities and connect them with OR for your solution, and then graph them. This has been Mr. Pilarski on solving compound inequalities containing OR. Thanks for watching. Bye-bye.